Hi guys, welcome to another episode of MrLopezClasses.com. Today we are going to continue in our diesel engines class. This is the chapter 12 dedicated to the fuel systems. This is a long chapter. We have a lot of episodes in this chapter because we are going to check the regulations and the system from the fuel tank until the injector. The different type of systems, mechanical fuel injection system, electronic fuel injection systems, and we are going to do the comparison with gasoline all the time. And we are going to check the standards and the regulations for fuel system, diesel fuel systems. And of course, we are going to prepare in this chapter in order to take the ABYC certification. For that reason, I recommend keep in your hand the ABYC diesel study guide in order to follow the chapters dedicated to fuel system and injection systems, and we are going to solve it questions related with those chapters in order to prepare for the exam, the ABYC diesel certification. Okay, my friends, this is a long chapter. We are going to start. This is the first episode of the chapter 12. About the regulations. In gasoline, gasoline fuel systems are covered by the Code Federal Regulations, Title 33, Part 183, and the ABYC cover the gasoline fuel systems in the standards H2, H24, and H25. This is for gasoline. In diesels, ABYC cover the diesel fuel systems in the standards H32 and H33. Yes, my friends, I recommend, if you have a chance, enter in the webpage of ABYC and try to buy the big book with all the standards. In that book, you found all the standards for all the certifications. Yes, when you have an individual ABYC study guide, this is a portion of the big book, the blue one, with all the standards. I recommend try to keep that book in order to check when you have questions related with some specific topic. You can clarify those questions if you have the blue book or the book of standards. All right, the CFRs, the Code of Federal Regulations, actually they don't cover diesel fuel systems. They only cover gasoline systems. Okay, ABYC is never contradict the federal law. ABYC is a good complement, and I recommend follow the regulations of ABYC. ABYC review and adjust regulations to keep up change in the industry. Yeah, ABYC is working together hand with the industry. The majority of the manufacturers, the marine manufacturers, are part of ABYC, are members of ABYC. The fuel system include the fuel, that's the first one, the tank, the vent, the distribution lines, the return lines, the pumps, the valves, the strainers, and the injection system. Those are the components of a typical fuel system, diesel system. Those are the components. Okay, my friends. You remember in previous episode I explained that the main difference between gasoline and diesel is that in diesel we don't have a spark. In diesel we only need compress the air full compressed, and when the air is full compressed we are going to inject a little amount of fuel. Yeah, this is possible because in the diesel engines we inject the fuel at high pressure. You remember the pressure that you have when the piston finishes the compression stroke at high temperatures over 1000 degrees Fahrenheit, and the pressures in some cases around 2000 psi or 3000 psi or higher, depending on the diesel engine. Yes, at that pressure the injector open and inject fuel. Of course, the injector should open at higher pressure than the pressure of the combustion chamber. If not, the fuel never enter. Yes, my friend. For that reason, those elements, the injectors, are criticals. And of course, these elements work together with the fuel injection pump. Yeah, this is a good schematic. In this schematic, we have the fuel tank. The fuel tank is over there, and this is the transfer pump. Those are the water separator filters or primary filters. This is the secondary filter, and this is the priming pump or lifting pump, and this is the fuel injection pump. That's the fuel injection pump. Okay, the fuel injection pump is the element that multiplies the pressure hundreds of times. Let me explain something. This pump, the fuel transfer pump, this one, is a low pressure pump. It's a pump that normally works, it's a 12 volts or 24 volts connected to the ignition system. This is the pump that you hear when you select ignition. That's the pump that bring the fuel from the tank into the fuel injection pump at this point, into the fuel injection pump here. Alright, but it's a low pressure, it's a 15 psi, 20 psi maximum, low pressure. In the output of the fuel injection pump here we have pressures over 600 psi, pressure superior to 600 psi, multiply from 15 psi into 600, 1000, 2000, 3000 psi. Yeah, this element is magic. The fuel injection pump multiply the pressure hundreds of times, thousands of times. Yeah, the input is 15, 20 psi, and the output more than 600. It's a lot. Of course, at that pressure, the injector open and spray the fuel. Yeah, this element, the injector and the fuel injection pump, they work together. For that reason, in the fuel systems, we are going to divide the system in two sections. From the tank until the fuel injection pump, this is considered the low pressure side. This is the low pressure side. In between the tank and the fuel injection pump. And between the fuel injection pump and the injector, between this point and up, is the high pressure side. Don't forget, high pressure side is considered from the fuel injection pump and the injector. Low pressure side is considered in between the fuel tank and the beginning of the fuel injection pump, the input of the fuel injection pump. And high pressure from the output of the fuel injection pump and the injector. Yes, those lines are heavy steel, heavy alloy, hard steel, because those lines internally support higher pressures. Yes, the fuel injection system is divided in high pressure side and low pressure side. Don't forget that. Okay, my friends, and of course the diesel engines, the troubleshoot is believe me, is very simple in comparison with gasoline. Why? Yes, because you don't need to follow a million of wires with signal for a spark. In diesel engine, you only need that the piston compress the air and that the injector open. That's it. If the piston compress properly, if the compression is good, the piston compress the air appropriated. If the injector open, the engine starts. You don't need a spark. You don't need nothing. It's too simple. The compression is good. The injector open. That's it. The troubleshoot is simple in comparison with gasoline. Mr. Lopez, but my diesel engine is electronic. It's complicated. No. Look at this. This is a mechanical fuel injector. Input and return. All the injectors have input and return. This one works with the pressure of the fluid. If the pressure is enough, the spring internally compress and inject the fuel. We are going to explain later this element. This one is too simple. This is the input and this is the return. That's the return, that's the input. And here, the signal coming from the computer activate the solenoid and spray the fuel, yes, no, depending if the signal is coming from the computer. This and this are the same, but this one open because an electrical signal enter and activate the solenoid, and this one spray the fuel because the pressure is enough and compress the spring and inject the fuel. In other words, we only need good fuel pressure and good air compressed. Good temperature and pressure in the air, in the combustion chamber, and appropriate fuel pressure. That's it. That's the only that you need to start a diesel engine. Good pressure on the fuel and good quality of fuel, of course, this is other important thing, and good temperature and pressure in the combustion chamber. Enemies of the fuel system in diesel engines. Air in the fuel system. Let me explain something. You remember in this particular case I said that at the input of the fuel injection pump the pressure is low pressure, 15 psi, 20 psi, and in the output is more than 600 psi in the output of the fuel injection pump. Okay, what happens if at the input of the fuel injection pump the fuel enter with some bubbles of air in the fuel coming from the fuel tank? The fuel coming from the fuel tank enter in the fuel injection pump here with bubbles, with air. What happened when internally in the fuel injection pump the plungers compress that fuel with air, with small bubbles of air? What happened with the diameter of those bubbles? Expand and block the system. Yes, my friends, for that reason you hear that the technician, the engineer said, oh, you change the fuel filters? Don't forget, bleed the system, remove the bubbles. Oh, I don't know what happened. I replaced the fuel filters and right now my engine crank, but no start. Air. No, air. You bleed the system? Yes, I bleed. You need bleed again. I bleed 3 times. You need bleed 5 times. 10 times. Until the last bubble goes out. With a small bubble, the engine not start. Yes. That's the difficult part in diesel. The diesel engines are delicate with respect to the quality of the fuel. The quality in terms of foaming, bubbles, and the quality with respect to humidity. Air in the fuel is not good. Air in the fuel is air in the fuel is not good, and water in the fuel is not good. Okay, if the water is salt water, that's catastrophic. You remember why. Okay, my friends, but those are the diesel engines, and we need be 100% sure that the compression of the engine is good, the rings are perfect, the valves close properly, the valves are properly calibrated. In other words, when the piston finishes the compression, the compression stroke, the temperature of the air is appropriate. This is the first condition, and the second condition is that the fuel, good fuel, enter at the appropriate pressure. Liquid, no vapor, liquid. With those situations, the explosion will be perfect. And after that, the engine continues running properly. Alright? Yes, my friend. We are going to study 2 different types of fuel injection system. We are going to study this one. This is the first one. This is mechanical fuel injection system. If you check, we are going to check step by step. We are going to start on the fuel tank. On the fuel tank, the fuel continue into the Raker-Parker filters or water separator filters or primary filters. Those filters, primary filters. After that, and the secondary filter, this is the secondary filter bolted on the block of the engine. Here you have the priming, the transfer pump. This is the fuel pump, 12 volts or 24 volts. This is the pump that brings the fuel from the fuel tank until the fuel injection pump. Okay, and this is the mechanical fuel injection pump. This is the mechanical fuel injection pump. We are going to study that pump in details. We are going to disassemble the fuel injection pump and check what happened inside of the pump. And the solenoid of the fuel injection pump is located here in this point, and that solenoid allows that the fuel enter in the fuel injection or not enter. That solenoid is activated if you check this purple color, purple is coming from the run relay. You remember the run relay when you did the harness? You remember the run relay? And the run relay is activated from the ignition position in the ignition switch. In other words, this solenoid, the solenoid located at the input of the fuel injection pump, like this one that you have on the screen right now, that solenoid open or close depending if the ignition switch is on or off. Okay, in other words, when the engine is running, this solenoid, the solenoid located at the input of the fuel injection pump, should be open. The fuel enter and the injection pump compress the fuel and send the fuel full compressed into the injector, and the injector open and spray the fuel properly. This is the mechanical fuel injection system. What is the secret in this mechanical fuel injection system? The alignment of the timing. You need align, you remember in the laboratory, you align the gear of the fuel injection pump with the gear of the crankshaft and the gear of the camshaft according with the marks. You remember in each engine we have a different configuration depending on the manufacturer. This is the most important part. If the engine is on time, you don't have any problem. Okay, this is the mechanical fuel injection system. It's simple, it's not complicated. What is the only electrical part in that system? The solenoid at the input of the fuel injection pump. And that solenoid is the power of that solenoid is coming from the run relay. ABYC question, quiz question. And the run relay is activated from the ignition position on the ignition switch. Very, very simple. You have the picture in this moment. Is a clear picture about the mechanical fuel injection system. Mr. Lopez, and what about the electronic fuel injection system? The electronic fuel injection system is basically pretty similar to the mechanical fuel injection system. Once again, we have the fuel tank, we have the transfer pump, we have the primary filters, we have the secondary filter here, that's the secondary filter, we have the priming pump. This is a manual priming pump. You can prime with your hand. If you don't want to use that one, with the electrical, with this one, you can prime the system. You can bring the fuel into the fuel injection pump. I recommend install the electrical, the 12 volts low pressure pump or priming pump. And this is the fuel injection pump. The fuel injection pump is located here. That's the input of the fuel injection pump, and this is the output. Look at this system. This is electronic fuel injection pump common rail system. Look, the output of the fuel injection pump, high pressure, more pressure than the previous mechanical fuel injection system. You remember in the previous one the output is in between 2000 3000 psi. In this one probably is higher. Okay, and with that pressure pressurized this common high pressure rail, and that common rail send the fuel at high pressure to each injector, and each injector receive the current to be activated from the computer. Each injector open and close. Each injector, electronic injector, receive the signal to be activated from the computer. This is the electronic fuel injection system common rail. This is pretty simple. This is nice. All right, we are going to study those systems separated, and we are going to analyze how those systems work. In this system, you need align the crankshaft and the camshaft. You don't need align the fuel injection pump, because the fuel injection pump is working constantly all the time. The common rail is full pressurized all the time, and the injector open and close. The injectors open and close when the computer sends the signal. I am going to explain that procedure And you understand 100% sure that at the end of this chapter you understand both systems easily. Okay, my friend, those are the systems that we are going to study in this chapter. All right. One important thing, in the diesel engines we have input and return. All the time in all the pictures we have the input of the fuel here, and this is the return. In general terms, my friends, the fuel enter here. 20% of this amount of fuel is used to produce power, and 80% return into the tank. Yes, a lot of fuel return. Only 20% pass through the nozzle and enter in the combustion chamber. 80% return. Yeah, a lot of fuel return into the fuel tank. 80%. What happened when the fuel enter, compress the spring and pass into the combustion chamber? At what temperature is coming this fuel? High temperature and high pressure. Of course, the excess of fuel, 80%, return into the tank at high temperature. What happened in a typical diesel engine after 1 hour of operation of the engine? What happened with the temperature of the fuel tank? Is hot, because the fuel return at high temperature. For that reason, in the majority of diesel engines, marine diesel engines, we are going to introduce the fuel cooler. You remember in the previous episode we studied how many heat exchangers, you remember? One heat exchanger for motor oil, other heat exchanger for transmission oil, other heat exchanger for air, the intercooler, other heat exchanger for raw water, the heat exchanger, and other heat exchanger for fuel. Yeah, because we need keep the temperature in the combustion chamber appropriate, not too much temperature. Remember, if the temperature pass 1400 degrees Fahrenheit, produce vapor lock. We need avoid that the fuel enter vapor, and we need avoid that the air coming from the turbo enter at high temperature, because immediately become vapor, the fuel, and produce vapor lock and deteriorate the valves and the head. Alright, in order to avoid that situation, we have two heat exchangers. One heat exchanger to reduce the temperature of the air is the intercooler or aftercooler. And other heat exchanger to reduce the temperature of the fuel is the fuel cooler. Yeah, both coolers are used to reduce the temperature of air and fuel and avoid vapor lock. ABYC question. Alright, very, very important, my friends. Okay, but we are going to analyze in each moment where should be located those heat exchangers and how those heat exchangers are integrated with the rest of the system. Okay, my friends. Other important thing is this. Remember, 80% of the fuel return into the tank. 80% of the fuel. And it's important that each engine have your own fuel tank. In a medium and big boat, normally there are two fuel tanks. One tank in the port side and other tank in the starboard side. Yeah, and it's a common recommendation that each engine return in the opposite tank in order to keep the boat stabilized. Each engine return in the opposite tank, cross tanks. And additionally, both tanks in the bottom, they have a communication with a valve in order to stabilize the level of the tanks and avoid that the boat be inclined in one or other direction. This is very important. But let me explain something about that. This is the balance. Those are the valves, and this is the transfer pump. It's a transfer pump in order to keep the level of both tanks at the same level. Those are the typical fuel tanks for marine diesel engines, and this is the connection in between both tanks. This is mandatory. This is the only connection in the bottom of the tank. In the bottom of the tank, right now we are going to study, is not accepted fittings, drain valves, nothing. All the fittings, all the valves should be located on top of the tanks. In the bottom, only those valves to communicate both tanks and keep the levels equal. The rest, you don't have any valves, any fittings in any other part of the tank. Those tanks should be completely clean. Very, very, very important. 80% of the fuel entering in the injector, 80% return, and only 20% enter in the combustion chamber to produce power. Okay, other important thing that we are going to study later is the bonding system. The majority of the fuel tanks for diesel engines in new boats are fabricated in aluminum series 5000, right now we are going to study, or stainless steel series 300. Special stainless steel, marine grade series 300, or aluminum. Those tanks are reinforced, and internally they have a special construction that we are going to check in this chapter. Okay, those tanks should be appropriately installed according with a lot of standards that I am going to get to use in this episode, and those tanks should be located appropriately with respect to the water line and the anti-siphons in order to avoid other critical situations. Okay, my friend, because the tanks are metallics, those tanks are in aluminum or stainless steel, those tanks should be connected to the bonding system. Remember, all the metallic parts internally in the boat, all the metallic elements through hulls, fittings, blocks, generators, cabinet, everything, the shaft, the propeller, all the metallic parts shall be connected to the bonding system and protected. If those metals are in direct contact with the salt water, protected with pieces of zinc or sacrificial anodes. Okay, in this particular case, the tank is an element that should be connected to the bonding system. And this is mandatory. We study the bonding system in detail. If you have a question related with the bonding system, I recommend that check my electrical book, chapter 10. The episode 1, 2, and 3 are dedicated to bonding system. Please check in my webpage, chapter 10, the electrical book dedicated to bonding system. Okay, but we are going to refresh quickly. Those are the elements that should be connected to the bonding system. All the metallic elements, fuel tanks, fittings, cabinets, the negative of the batteries, and everything at the end of the day finish into the zinc. The zinc is the element where the bonding finishes. You remember in the chapter dedicated to bonding, I explained that internally on the stringers you have pieces of metals, and those pieces of metal at the end should be connected with the zinc on the transom of the boat. Okay, those pieces of metal normally are solid pieces of metal. Normally is a copper or a bronze strip or a copper pipe with too much holes, with drill it with tap in order to insert the bolts and connect the cables of the elements. Okay, if all the cables for bonding system should be number 8. A is the number appropriate for the bonding cables. And what is the color of those wires? The color is bare, or is a green color. Normally is a green cable. The number of that cable should be number 8. Okay, my friends, and those are the elements that normally are connected to the bonding system. Engines, propeller, cabinets, electronics cabinets, fuel tanks, water tanks, fuel pumps, valves, the boxes of the batteries if the boxes are metallic, the conduit, the piping, the flaps of the twin taps. Okay, my friend, don't forget, I need that you keep clear the difference between grounding conductors, grounded conductors, and ground. Okay, before that, I'm going to refresh our electrical concepts and what is the difference between grounding conductors and grounded. Okay, the grounding conductor is basically the green cable that connects the case of the elements to the bonding system. Those green cables are the grounding cables. Those cables are considered non-current carrying conductors because normally you don't have current on those cables, on those green cables. Those green cables are installed for emergency in order to drain currents. What type of currents normally is moving on those cables? Small DC currents, a small static current. All right. Oh, and what happened during the storm? Okay, in some situations, drain heavy AC current. If you have a short on the water heater, drain AC current. If you have a short in a generator, drain AC current. But normally, drain those grounding conductors, they drain a small DC current. Okay, what is this is a grounding conductor. Is the green cable and is normally non-current conductor. Okay, the other one is the grounded conductor. The grounded conductors. Those cables are current carrying conductors. For example, the negative of the batteries. The negative is considered the grounded conductor and is current carrying conductor. Remember, the same amount of current flowing through the positive is returning through the negative. Yeah, those are current carrying conductors. The name of the black cable, the negative cable, the return is the grounded conductor. That's different. Grounding conductor are the bonding cables, and grounded conductor is the return. In AC, remember you have 3 cables: black, white, and green. No? Okay. The black is the hot. The neutral is the return. And the green is the ground. And additionally, you have bonding from the case to the bonding system. Okay, my friend? I hope that you have cleared that situation. And what is the meaning of ground? Oh, is the connection directly to the earth. In your boat, that connection is the sink, because the sink is connected with the water and the water with the ground. Finito. Okay, this is very, very important. My friend, all the time I am going to talk about the comparison in between gas and diesel. For that reason, always I am going to show the reference in between gas and diesel. The majority of the gas systems are tested at a 3 psi, 3 psi of pressure. For example, the fuel tanks for gasoline, those plastic red fuel tanks that you have in your small outboard boat, those tanks are tested at a pressure of 3 psi. It's practically nothing. This is a low pressure, but they should pass the test of the 3 psi or 1 point times the pressure at the lowest point of the tank. In the class of gasoline, I am going to explain the procedure to test those fuel tanks for gasoline. Okay, in diesel, the situation is a little different. We are going to take some considerations with respect to the fuel tank. The fuel tank should be metallic. The fuel tank should be separated from the structure of the boat. In other words, the fuel tank is recommended that no structure, be separated from the main structure of the boat. Right now I am going to explain what is the meaning of that. Okay, of course in the fuel tanks is not recommended, is not authorized, is a problem, is a complaint. If the Coast Guard or the inspector visit your boat and found drain plugs in the bottom of the tank, this is immediately a complaint, and you need eliminate those drain plugs. Exactly the same, any type of valves in any lateral side of the tank or in the bottom, if you need valves, if you need fittings, all of those elements should be located on top of the tank. On the side or on the bottom, nothing. If a filter or drain plug has a service fitting, it must either be tapered pipe, plug, or screw type. Yeah, I am going to explain right now what is the meaning of that. And all gasoline fuel systems must be pressurized according with the manufacturer of the fuel tank. Let me explain what is the meaning of that. We are going to talk right now about the hoses, fuel hoses. All the fuel hoses should be marine approved, marine grade, and if they have the labels on the side of the hose, and the label included the year of manufacture, the manufacturer additionally, and the type of hose. This is very, very important, what type of hose. And those fuel hoses are reinforced, wire reinforced. For that reason, cutting those hoses is not easy. Don't try to cut it with cut those hoses with the regular handsaw or with tools not appropriate. I recommend, if you need fabricate fuel hoses, I recommend visit special shops dedicated to hydraulic hoses and fuel hoses. I love in particular hydraulic supply, but there are a lot of companies dedicated to install fittings and cutted hoses appropriated for fuel system, especially for diesel system. I recommend that you visit a place dedicated. Types of hose. We have 4 types of hose: A1, A2, B1, and B2. What is the hose that is good in all the situations? Is the aspirin of the hoses? Type A1. Type A1 cover all the standards, meet all the standards. But right now we are going to check what is the difference between A1, A2, B1, and B2. Okay. The leathers, be careful with the leathers. The leather, this is the nomenclature, is 1/8 inches block leathers, then the name of the manufacturer and the logo, the year of the manufacturer. This is mandatory on the hoses, all right? This is part of the hoses. Type of hoses. A1. A1 can be used anywhere in fuel system. What is the meaning of that? That hose can be used in the low pressure side, in the high pressure side, in the fill, in the vent, in the return, in any part of the fuel system, you can use type A1. Right? What about type B1? Those hoses are okay for vents, for fills, if the hose will leak less than 5 ounces in 2.5 minutes. In order to avoid that confusion, use type A1 for everything. Yeah, B1 can be used basically for fills and for vents. For fills and vents. B1. Alright. I recommend A1 for everything. The hose clamps. My friends, use appropriated hose clamps, marine grade. Marine grade is stainless steel, series 300. Those are the hoses appropriated. Okay, recommendations about the installation of the hose clamps. The clamps not to overlap each other. What is the meaning of that? The recommendation in all the fittings with hose is double hose clamps. mandatory in all the fittings. Double hose clamps, and the hose clamps cross. With the end of this, the end of the second one facing in the other direction. Cross. And separated. Quarter inch in between both of them. Never that this one lap the second one. Separated a quarter inch and marine grade and opposite position. Okay, a quarter of hose beyond the clamp, hose clamp no spring tension. Okay, what about this hose clamp? Commonly used in automotive gasoline lines. Is not recommended in marine. Is not approved. All right, be careful. Never install those types of clamps in marine application. It's not authorized. Never, under any condition, try to put those clamps. And this one, this is for gasoline, not for diesel. For diesel, this is the hose clamp recommended. Marine grade, series 300, 302, 304, 316. Right now we are going to talk about that. Series 300, marine grade. The other ones no, because this one, like a spring, remember, the iron have good memory. If that hose clamp was extended for 5 years in this position, that hose clamp right now compressed? No, not compressed appropriated. In the moment that you extend to remove it, when you try to close again, not close. This is not good for diesel, because in diesel you move higher pressures, excessive pressure. All right, be careful with that. Okay, the fuel fill system. The fuel system. Okay, the most important part is install the socket for the fuel system in an inclined angle. Never in a flat angle, because you accumulate water around the fitting. In an inclined surface. All the boats, they are designed with those areas inclined in order to install the socket, the fitting, to fill the fuel tank. In order to avoid that the water pass and never penetrate the boat. And never penetrate the tank. Of course, this is the most important part. The fuel fill must be located in a way that an overflow superior to 5 gallons for 5 seconds no enter in the boat. That's the design. All right. Never install those elements in a pocket, in a recess of the fiberglass like this. Like this. This is not authorized. This is not good. This is a wrong installation. Okay. Other important thing. ABYC question. The fuel fill socket must be at least 15 inches from any vent on any exhaust gases outlet. All right, separated 15 inches from any vent or any exhaust gases outlet. That's the separation, 15 inches, ABYC question. And the hose should be type A1, mandatory. Type A1 is the recommended. All right, and once again, double hose clamps, cross clamps, important. Type A1. And the vent. The vent is very important. What is the function of the vent? The vent prevents that the tank expand more than 80%. Very important. This is very important. Prevent that the tank expand more than 80%. Other important function is flame arrestor. And other important is that the vent not allow that the fuel enter in the boat during an overflow, of course. All right. The vent releases excess amount of gases produced internally in the tank. Keep the tank pressurized no more than 80%. Avoid that overflow enter in the tank, and avoid that ants and flies enter into the fuel. Okay, the installation of the vent is not easy. The vent should be installed properly. You need a small anti-siphon on the vent, like this. Yeah? Look, this is the vent, and this is the anti-siphon here, in order to prevent that water enter into the fuel tank. Very, very, very important. Must not allow fumes to enter in the boat. Keep at least 15 inches away from other vents. There should be no traps in hose that would impair the ability of the tank. Yeah, of course, this is very important. And keep those hoses clean, completely clean. It's good idea periodically with air at high pressure remove particles, ants that are located on those hoses. Okay, my friends, this is the very important related with the vent and the diameter of the hose. The diameter of the hose is 9/16 inches internal diameter. You can use for the vent A1 or A2, ABYC question. Okay, my friends?